Hello everyone. Today we will present how Skydive, an open source real-time network topology and protocols analyzer, can help explore and debug Kubernetes landscapes. Skydive captures the network topology using graph nodes to depict hosts, containers, interfaces, bridges, switches, etc., and using graph edges to depict relations between nodes, ownership, L2 connectivity association, etc. We recently added a Kubernetes topology probe which captures Kubernetes entities via the Kubernetes API server endpoint and tracking entities such as pods, containers, network topology, services, etc. For the purpose of this demonstration, we're going to use BookInfo. BookInfo is a typical cloud-native application consisting of 4 microservices. Product page, which generates a main application frame depicting a book for sale. Details, which provides product page with details about the book. Reviews, which provides product page with 2 review entries for the book. Rating, which provides each review entry with a 1 to 5 star rating. As is typical with cloud-native applications, a microservice comprises of multiple instances and these are upgraded gradually, resulting in potentially having multiple instance versions alive at any given time. The Reviews microservices has 3 instances, each of a different version. Reviews version 1 only displays the review text. Reviews version 2 adds a rating indicated by black stars. Reviews version 3 indicating rating with red stars. Now we look at the BookInfo application running on our Kubernetes cluster. On the screen we can now see the page generated by product page. On the left, the book details frame. On the right, the book reviews frame. Notice the red stars in each of the 2 review entries, this indicating that Reviews version 3 instance was responsible for generating the reviews frame. And on each page refresh, 1 randomly selected reviews instance is used to generate the reviews frame. We refreshed the page and we can now see no star rating, indicating that Reviews version 1 instance was the one that was called. We refresh yet again and now we get an error message suggesting that Reviews version 2 instance is not working properly. Now let's use Skydive to troubleshoot the BookInfo application. Let's start by focusing on compute. If we select compute and then expand BookInfo, we will identify that all the expected instances are running. Product page, details, reviews version 1, 2, and 3, and rating. When clicking a graph node, you will see on the right panel the metadata field, which contains all searchable attributes. Some attributes, such as name, are standard, while other attributes, such as Kubernetes namespace or Kubernetes labels, are specific for Kubernetes graph nodes. When scrolling down the right panel, you will notice Kubernetes extra field, which contains a raw representation of the Kubernetes resource. Kubernetes extra is not searchable, but nonetheless it is still beneficial to store it in Skydive, as Skydive is backed by Elasticsearch, which is a time series database, enabling for historic time travel. Now let's use what we have learned to highlight graph nodes of interest. Let's highlight all the review objects by using a gremlin expression in which attribute Kubernetes labels app is equal to reviews. Running this highlight expression will yield 3 graph nodes: pods reviews version 1, reviews version 2, and reviews version 3. Next, we can focus our highlight by adding that attribute Kubernetes labels version is equal to v2. Note that in any case, the highlight nodes is a subset of filtered nodes on display. And in this example, we have been using the compute filter. The only objects which are highlighted are pods, but under other filters, other objects will be highlighted. Now let's select the network filter. The landscape is regenerated and we now expand the cluster and then BookInfo. Notice we see network policies interconnecting pods. Also note that Kubernetes traffic is allowed between pods either implicitly when no network policy exists or explicitly if at least one allow network policy exists. As we have a deny network policy with its unique edge arrowheads colored red, all traffic is blocked by default, forcing us to explicitly allow traffic via allow network policies, edges of which have green arrowheads. We have ingress policies from product page to reviews version 1 and reviews version 3, but are missing such a network policy to reviews version 2, suggesting that this is the root cause of the error page displayed on BookInfo application earlier. Let's try to fix the issue we discovered by creating the missing network policy between product page and reviews version 2 using kubectl command. Now let's return to the BookInfo application. It is still showing the error page we previously got. We refresh and get reviews version 3 with red stars. We refresh yet again and now get reviews version 2 with black stars. BookInfo application is now working correctly. In this demo, we used skydive Kubernetes probe to debug an error in the deployment of the BookInfo application. And by using skydive, we were able to identify the root cause, ultimately enabling us to fix our application. Thank you for watching.